Hello all and welcome back. So in this assignment, you have to solve the question, delete a node at an index, but we have to do the same recursively, right? So we have done it using iteration. So the flow is going to be the same. Let me draw a linked list. Let's say this is our linked list for the time being, everyone. Now in recursion again, we have to just follow the framework. So first is the base case. Base case, I believe, is very easy. Like if head becomes, or if head is none, like you're giving me an empty list, then how can you expect me to delete anything, right? If head is none, how will I delete anything? Okay, and think in terms of recursion just, right? You have to make sure that you are handling some part and else recursion will handle, right? Great. Second is going to be your recursive call. And third becomes our work, right? Now, in this, if we pay attention, everyone, so recursive call is pretty easy. Again, we are just going to call recursion and just make index -1. But I think again, we can do our work first. What if you are asking me to delete the first node, like the index is 0? Then I think we have already seen in that. So this is going to be our work. If index becomes 0, then we will simply return head.next, right? We have already made sure that head is not null. That's the base case. If index is 0, then we will delete it. And if that is not the case, then okay, let recursion do the work. Head.next is equals to delete head.next and index -1, right? So yeah, just this is how we can handle it. Again, these are interchangeable. Till now, we have done lots of problems on recursion, so I'm pretty sure that you will be able to understand why each and every step is done here. So let me do this, everyone. Now define delete at index recursion, right? I will be getting an head and an index. Great. If my head is none, I can just simply return none. But along with that, I should tell that, hey, the index is out of bounds. Index is out of bounds. Great. So once that is done, then maybe we can move on to the next case. Let us do our work first. If you are asking me to delete the first one, I'm just going to return you head.next. Now here we have already made sure head is not none, so we don't have to worry if this will give an error, right? If that is also not the case, then I'm just going to use recursion. Okay, so I don't need to worry on anything. Recursion is going to do all the work for me. So head.next and index -1. Once recursion does the work, I can just return head. Okay, cool. So yeah, I think this is what we can do. Let us just test it out once. Yeah, maybe we can work with this. Great. Clear. Let us run this. 10, 20, 30, 40, 50, -1. Okay. So yes, we are able to delete this part, right? Let us check this for an empty linked list. Index is out of bounds because we are giving head as none and we are asking for 3. Now, one thing again to notice here, everyone, even if the index is 0, right? Even if you want to delete the head, but head by default is none, then of course you cannot do anything, right? If head is none, then it's an empty list. So please make sure that you handle this in a similar way. Now, next part, which we should test as well is this question, right? So 10, 20, 30, -1. If you remember, we faced an issue in the iteration part here, which we solved by this condition. Will we face the same problem here? Let us see. Okay. No, this seems to work, right? This seems to work. So let us understand how this is working, everyone. This is a lot important to understand once. See, again, just make the recursive calls and let me draw the linked list vertically this time so that I can tell you what the recursive call going to be. 10, 20, 30, and none. right? See, the very first I'm getting my head as this and index is 3. Makes sense. Next I'm getting my head as 2 and next I'm getting my head as sorry, head as 20, index at 2, head as 30, index as 1. So again, all these are still not done and I reach this condition. In this condition, my head is none, index is 0. Then again, if you think about this, if I just give you an empty linked list with the index 0, of course you cannot do anything, right? It's an out of bound, you can just print. So this condition is going to get hit first. In the iterative part, we have to make sure that we handle that because we were handling everything. In this, recursion is doing the work plus this condition, the way we have handled this, that is making all the difference, right? Because in this particular case, you are passing none. And if index becomes 0, okay, it kind of signifies already that, hey, we seem to be somewhere, okay, the linked is empty, so you cannot delete anything, right? So that's why we are getting that answer. And again, even if it is on tail, right? Even if it is on tail, when we call on this particular, let's say this is the tail, right? 30 is the tail. So that was where the major problem was happening in the iteration part, right? But in recursion, we actually call on tail and it is none, right? So that's why it gets taken care of in this case when the head becomes none and index becomes 0. Again, if the index will be greater than 0, that is 1, 2, 3 something, then again we are going to do the same thing. Okay, everyone. So I hope this is clear. Again, that was just one caveat which was there in the iterative part as well. So yeah, just let me clear this. Great. So we can just quickly do it once. 10, 20, 30 minus 1. It's giving me the same thing. Index is out of bounds. After deletion, the same list is there. Okay. So great, everyone. I hope you were able to do the same. Again, please make sure that you follow the framework and try to do these questions. These are the kind of questions which are normally asked. Moving forward, we are also going to do one very easy but medium level question on link on your lead code, which is based on the same principle. Okay. Thank you.